And in this last section of chapter 2 in the 8th grade book, we're going to talk about dilations. So what is a dilation? Well, think about it. If you know what dilate means, you've probably been to the eye doctor. When the eye doctor or the optometrist dilates your eyes, that means your pupils, usually get bigger. That means they've been dilated. So dilated means what? Well, a dilation is a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. This is important to understand here. Now, these are similar figures. They're not congruent. So this is not a rigid motion. Now, the center of dilation. Notice that I could actually connect the corresponding vertices, and I could connect these as well. I could also connect these. Everything is similar. That's important to note. Now, what do you know about the angles, though? Like this angle here and this angle here, this angle here and this angle here. They'd be congruent because similar figures have the corresponding angles that are congruent. The first part is fairly easy. Tell whether the blue figure is a dilation of the red figure. Well, if you look at A, this is what you need to do. If you connect the lines, like if I just start here, red figure is a dilation of the blue figure. So that means we go this way. If you connect them, if you use the ruler, you would get it. You would notice that all three of them connect at a point. Therefore, the blue figure is a dilation. Now, in B, the figures have the same size and shape, but the red figure slides. And if you actually connected the vertices, they will never connect at a point. Therefore, it is not a dilation. Here's your key idea. In dilation, the original figure and its image are similar. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is called the scale factor of the dilation. The scale factor is represented by the letter K. To dilate a figure with respect to the origin, you're going to multiply the coordinates. Here's what you do. You're going to multiply the coordinates of each vertex by the scale factor. So if I have an ordered pair of x, y, and the scale factor is k, I multiply each coordinate by the scale factor. Now, if the scale factor is greater than 1, let's use common sense here. If you're multiplying by a number bigger than 1, the dilation is going to be an enlargement. Now, if it's between 0 and 1, 0 and 1 would be a fraction. It's less than 1 but bigger than 0. It's a reduction because you're getting smaller. So in example 2, draw the image of triangle ABC after dilation with a scale factor of 3. Identify the type of dilation. So here are your vertices. A, B, and C are those points. Now the scale factor is 3. So all I have to do is what? All you have to do is multiply each x and y coordinate by 3. If you multiply each x coordinate by 3, this is what you're going to get. Notice this is the algebra. I multiply each one by 3, and my new vertices, which would be called A prime, B prime, C prime, would be those 3 points. Now if you graphed it, you're going to get a pre-image, which is triangle ABC, and then you're going to get triangle A prime, B prime, C prime, which is then going to give you this graph right here. Make note that you do not have to draw these lines, but it's good to note or good to look at to see that each of these represent the vertices that all meet at a common point, which is called what? What is this point called? the center of dilation. So what is this? Well, it got bigger. It's 3. You multiply by 3. This is an enlargement. So when we look at this in this problem, we're going to draw the same image of a rectangle, WXYZ, after a dilation with a scale factor of 1/2. So we're going to multiply. Here's all my vertices. You multiply each x and y coordinate by the scale factor of 1/2, and everything becomes half. So you get the vertices of W prime, X prime, Z prime. I'm sorry, W prime, X prime, Y prime, Z prime. So the red figure is here. The blue figure, which is your prime figure, got smaller. Therefore, it's a reduction. Now in example 4 and 5, we're going to talk about doing more than one transformation. So we could use rotation, translation, reflection, or dilation all in one problem. So the first thing we're going to do is we're going to graph the vertices of that trapezoid. So graph the vertices of the trapezoid. And I'm going to pause the video, and I'm going to do that for you. Now I've listed the ordered pairs right here. The first thing we have to do is dilate the trapezoid with respect to the origin using a scale factor of 2. That means my new ordered pair is going to be 2x, 2y, which means a prime is going to become what? I multiply by 2, that gives me -4, -2. Good. B prime. Fill out the rest. So I've drawn that trapezoid in red. Now I want to do what? I want to translate, which means I'm going to go x plus 6, since I'm going to the right. 2 units up, I'm going to add 2. So fill those out. Well, a double prime then would be what? Well, -4 plus 6 is 2. -2 plus 2 is 0. So if you drew it, it would look like this. So this would be trapezoid A double prime, B double prime, C double prime, D double prime. Now the image of a translation, reflection, and rotation is congruent to the original figure. And the image of a dilation is similar to the original figure. So two figures are similar when one can be obtained from the other by a sequence of translations, reflections, rotations, dilations. Now, if there's no dilation, the end picture is congruent. If there is a dilation, somewhere in there, it will be similar. Now, these are actually going to be a little harder than they appear. And there's multiple answers. That's important. There are so many answers you could have. The red figure is similar to the blue figure. Describe a sequence of transformations in which the blue figure is the image of the red figure. So we start with the red figure. That means the red figure is what? The red figure would be the pre-image. So if we look at it, we notice the picture is smaller. So we know we have a dilation. So I wonder what that is. Well, let's kind of take a look here. So if we have 4, -2, and it's going to become that point, which is 2, 1. So let's think about it. 4 is going to go to 2, so that's taking half. So let's try do this. Let's try to dilate with a factor of 1/2. So I'm going to take these points. So let's see, 4, 2 would become, or 4, -2 would become 2, -1. And it looks like 8, -2 would become 4, -1. This point here would be 4, -4. That becomes 2, -2. And the last one, 6, -6 becomes 3, -3. So does that look similar? Let me redraw it here. Okay, that's even worse. Let me redraw it again. All right, so there's my figure. So then how would I go from this red figure to the blue figure? Well, you'd reflect it. So we'd first dilate by a factor of 1/2, and then we're going to reflect where? You're going to reflect over the x-axis. So one possible sequence with respect to the origin would be using a scale factor of 1/2 followed by a reflection in the x-axis. There is one possible sequence. And your vocabulary words would be dilation and center of dilation.